Hello, everyone, and welcome to today's webinar, Actinovate, the proven broad-spectrum biofungicide. My name is Matthew Grassi. I'm the editor of Greenhouse Management Magazine, and I'm so glad you could join us today for this webinar. In this webinar from Mycorrhizal Applications, we'll be hearing all about Actinovate Biofungicide, as well as the unique advantages of biological fungicides in horticulture. But before we get started, I do have a few housekeeping notes to share. This webinar is being recorded and it will be available in a few days for download on our websites. We will have time for questions towards the end of this webinar as well, so please submit your questions anytime by using the Q&A function in your Zoom bar. Now a little more about our speakers today. I am pleased to introduce today's speakers, Randy Martin, the Global Technical Development Specialist with Valent Biosciences, as well as Blair Busenbark, Sales and Commercial Marketing Manager with Mycorrhizal Applications. In a career spanning over 33 years, Randy Martin has been dedicated to developing innovative biorational solutions for agriculture and horticulture. He has held multiple positions with several companies throughout the industry, and he has worked with a variety of technology platforms, performing many duties, including early development field research, late phase product development and regulatory studies, commercialization activity, technical support, and pipeline management. In his current role with Valent Biosciences, Randy serves as the primary global technical resource for Valent Biosciences biorational soil health products. He also manages the global R&D programs for the broad range of biorational soil health products in development for Valent Biosciences and its affiliates, and he serves as chairman of Valent Biosciences Soil Health Advisory Board. Randy earned a PhD in entomology from Texas A&M University, an MS degree in entomology toxicology from Clemson University, and his BS in animal ecology from Iowa State University. Our second speaker, Blair Busenbark, has a varied background working in the ornamental horticulture industry for over 25 years. He received his BS in plant science from the Utah State University and his master's in horticulture and his MBA from the University of Maryland. His academic interests include plant physiology, finance, and marketing. Blair's employment experience includes serving as the purchasing manager for a mail order nursery, marketing, sales, and product management at a flower seed breeding company, business development and marketing management at a large soil and peat manufacturer, and now today as a sales and commercial marketing manager for a leading mycorrhizal producer. In the early 2000s, Blair became acquainted with mycorrhizal technology as a customer of Mycorrhizal Applications. And in 2016, he joined the company in his current position. In that current position, Blair is able to combine his horticultural and business education and experience to help greenhouse and nursery growers and landscapers realize the fantastic potential of the use of biological and biorational solutions in horticulture. As Blair's experience working with microbes continues to expand, the more he works with these beneficial soil organisms, the more he has realized the value these biological options can truly provide to growers. So with that said, I will now turn it over to you, Randy and Blair.
All right, well, thank you very much, Matthew. I am Randy Martin with Valent Biosciences, and my pleasure to be here today to present the technical portion of this presentation about the exciting product that we know as Actinovate. Here's a quick overview of the presentation that myself and Blair will present today. A little bit of background information. We're going to talk about the modes of action of Actinovate, as well as some key additional benefits. Of course, some shelf life and storage notes for everybody. We will review some trial data, and then we'll talk about some frequently asked questions about the horticulture use of Actinovate, what are the top 5 pathogens, and then finally we'll end with the Q&A session. All right, well, what is Actinovate? Actinovate is a unique, broad-spectrum biofungicide for controlling both soil and foliar disease pests. Actinovate has multiple modes of action, which makes it ideal for use in an IPM program, including for resistance management. Actinovate comes with an easy-to-use, stable formulation, which allows for great flexibility in application systems, and it really can fit in all production systems. The other interesting fact about Actinovate is that it has been in the market for 15 years, so it's well established. There are a lot of people using Actinovate in their rotation, in their pest management program, and a lot of satisfied customers. Well, what is the active ingredient in Actinovate? It's a patented strain of the bacterium Streptomyces Lydicus. Well, Streptomyces are a very interesting and unique group of bacteria because they're fungus-like. And the reason they're fungus-like is because they produce these filamentous vegetative hyphae that you see here in this photo. And this is the only group of bacteria that produces that. The Streptomyces group is a very large and diverse genus of bacteria, and there's over 800 described species today. And another interesting thing about Streptomyces is that they produce approximately 2/3 of all clinically used antibiotics. And these include many anti-cancer drugs as well as other drugs. So of course, people are very interested in this group of bacteria and constantly collecting and trying to discover new strains and look for new uses for Streptomyces. Another interesting fact about Streptomyces is that it's Streptomyces that cause that earthy smell of soil. I think we've all smelled that if we've ever dug our hands into the soil, especially after a rainfall or an irrigation. We describe that smell as an earthy smell, and that's really caused by Streptomyces. I wanted to share quickly this overview paper that was published in 2016, and I think it's very interesting because, as I mentioned a minute ago, scientists around the world recognize Streptomyces as a group of organisms that has great economic importance, not only in agriculture, but also forestry, and of course we talked about medicine. This particular review paper is based on Streptomyces as plants' best friend. And here's just a couple of conclusions that they came to about the group. It's a very versatile and diverse group. We talked about that just a minute ago. For both plant health and growth, they contribute to disease suppression, which of course is the primary function of Actinovate. They have antifungal and antibacterial activities, and they also have the capacity to enhance plant biomass. In other words, it helps the plant grow. All right, let's get back to Actinovate now. It contains the strain of Streptomyces Lydicus called WYEC108. And this strain was discovered by Don Crawford in his lab at the University of Idaho in the mid-90s. And there you see the title of his paper that was published in Applied Environmental Microbiology. Don Crawford actually got this strain originally from the roots of a linseed plant isolated in the United Kingdom. And during the process of screening, they screened over 250 bacterial isolates, many other Streptomyces, but also other bacteria, because they were looking for things that could be used in a biofungicide program. And this particular strain, the WYEC108, really stood out among all the 250 isolates as the one that worked the best and most consistently. In fact, it was so unique that they applied for a patent, and a US patent was granted in 1993. Well, how does Actinovate work? There are really four primary modes of action that we're going to talk about today. And I show this picture because I really want you to start thinking about roots and the root system and root exudates, because that's really the key to how Actinovate works. So the product contains approximately 10 million spores of the Streptomyces Lydicus strain in each gram. When you apply this product, the spores will germinate and start to grow, and then they colonize the plant tissue. In other words, they're growing very close, in close contact with that root system. And in fact, they grow along with the root to protect the root as the root develops. And in doing so, it protects that root from attack by pathogens. These living bacteria need to grow and colonize. So we need to get the material out early in the life of the plant so they can set up shop, as I like to say, and continue to protect that plant. Now, the specific mechanisms that it actually uses to prevent plant disease, we're going to talk about in the next few slides. And there are several of them, which again, as I said earlier, makes it an ideal product to use in an IPM, integrated pest management program. So there are really four modes of action that we're going to talk about, and these are listed in order of importance. The first one is what we call antibiosis. The bacteria actually produce chemical metabolites that will slow down or inhibit growth of the pest pathogen. Next to that root system in what we call the rhizosphere. And once it gets set up, it's very competitive against other organisms, including pathogens, and it will outcompete for space, and it will outcompete other organisms for nutrients. The third mode of action is actually direct predation or parasitism. So the Streptomyces will actually attack and feed on pathogenic organisms. And the fourth mode of action is what we call induction of host plant resistance. And there's two mechanisms. One's called systemic acquired resistance, or SAR. The other is called induced systemic resistance, or ISR. And we'll talk a little bit more about each one of these. All right, antibiosis. Well, remember we talked about the fact that Streptomyces produce approximately 2/3 of the antibiotics that are used today in medicine. Well, these are natural antibiotics that prevent microbial growth. And this is exactly what's happening when you put this product out for use against pathogens. So these antibiotics are produced, and they can include, also include enzymes that will degrade pathogen tissue, such as chitinases, glucanases, and peroxidases. So in a sense, we're not delivering the pesticide, but we're delivering the pesticide factory. We're delivering the organism that sets up shop and produces these compounds that will inhibit the growth of pathogenic organisms. And you see in the picture here, this is a classic test of antibiosis. You see in the top photo here is a petri dish that's covered with Rhizoctonia solani. You can see that it's grown all the way to the edges of the plate, nice mycelial growth. Now, when you put the Rhizoctonia in the plate, as well as the Streptomyces from Actinovate, you see what's called a zone of exclusion. So this Actinovate organism is producing these metabolites that can move out into this nutrient agar and prevent growth and establishment of this pathogen that we call Rhizoctonia. All right, moving on to competitive exclusion. And this is really based on the concept that two species that are competing for the same resources cannot coexist. As I mentioned, Actinovate is an aggressive growing bacterium. If you get it into the system and get it started, it can outcompete most other microorganisms in the soil. So it grows and it covers this growth niche in the rhizosphere, depleting critical resources that other organisms would need to survive there. And this is kind of shown in this diagram here, where we talk about the rhizosphere, which is that very narrow, thin area that's influenced by root exudates. And you can see over here, these root exudates include things like sugars, lipids, carbohydrates, other nutrients, and that's what the actinovate is really feeding on. Now, actinovate also produces compounds called siderophores, and siderophores are unique because they can help to solubilize and move certain metals, especially iron. This is really a key for those crops that typically need a lot of iron. So very important to those crops that need iron. All right, the third mode of action that we talked about is called microparasitism. And this is actually a direct parasitism or attack or predation, if you will, by the actinovate bacterium on pathogenic fungi. And some of the things that it can do is it can inhibit spore germination by the pathogen. It can also reduce or even prevent the growth of fungal hyphae. It's kind of hard to see in some of these pictures, but these are micrographs showing, there's the YEC, that's the actinovate material, actually using one of those filaments to attack a pathogenic organism that you see right here. And that's what this photo shows here as well. All right, the final mode of action that we mentioned was called induced resistance. Now, plants do have an immune system of sorts that's certainly not as sophisticated as mine or yours, but they do have an immune system, and it can be primed or activated by microorganisms like actinovate. And when this is activated, it will reduce the effect of the pathogen, and it will make the plant less vulnerable to attack or future attacks by pathogen. And as I mentioned, two mechanisms which scientists classify differently, and they're a little bit different because it just depends on which genes or gene systems are activated by the presence of the bacterium in actinovate: induced systemic resistance and systemic acquired resistance. And this can happen in the foliage, and it can happen in the rhizosphere. All right, some additional benefits from actinovate is what we call the Pgpr effect. In other words, actinovate can help promote plant growth. And remember that review article that I showed many slides back? They really focused on that particular benefit of Streptomyces as being one of the key benefits. Now, Pgpr stands for plant growth promoting rhizobacteria. And this was a term that was coined back in the 1990s when researchers were studying bacteria and how they could promote this plant growth. And we've since discovered that it's not just bacteria, but there are other organisms, including beneficial fungi, that can have this effect as well. So some people have changed that term to Pgpb, which stands for, or Pgpm, I'm sorry, which stands for plant growth promoting microbes. So you might see either one of those terms in the literature. Now, we've seen this response in the actinovate trials that we've done in the field, but we haven't systematically evaluated this effect because it can be inconsistent. It's not something you can rely on. It's very situational. It depends a lot upon the plant host itself, any kind of stress that it may or may not be under, the availability of nutrients, and things like that. But the bottom line is that this Pgpr effect is real, and it really encompasses and can encompass a lot of different things. And that's what this diagram here illustrates. You know, one of these is hormone production. So just the presence of the actinovate in the soil can trigger the plant to produce certain growth hormones. We talked about nutrient uptake, especially iron, but the Pgpr effect also can influence and make plants more efficient in their nutrient uptake. We talked about siderophore production, very key in those plants that require iron. And then, of course, there's the biological control aspect of Pgpr, which is really the primary function that Actinovate does in the soil, is it inhibits the growth of pathogenic organisms. Once you inhibit the growth or eliminate those pathogenic organisms, then that plant can grow and utilize nutrients that are in the soil and grow taller than and larger than a plant that may be under stress from attack by pathogens. All right, let's talk a little bit about shelf life and storage of Actinovate. I know this sounds obvious after all the things that we've just been through in the last few slides, but just a reminder that Actinovate contains living organisms and they need to be alive to be effective. So, as users, you really have to pay attention to storage instructions. Actinovate has a 1-year shelf life from the date of manufacture. And one of the things that you'll see in the packaging of Actinovate products is these little moisture and oxygen scavenger packs. And these are adhered to the inside of packaging, and our advice is to leave them alone. You certainly don't want them to fall out of the container and into a bucket or other application equipment. All right, we're going to talk about some Actinovate trial data in the next few slides. Now, most of these trials were done on agronomic crops, but they certainly translate to horticulture crops as well because the pathogens are the same. So here's a trial that was done in cucumber seedlings by a professor at Auburn University, focused on suppressing or evaluating the effects of Actinovate on Pythium ultimum, which is a common greenhouse pest. And this trial was measured by looking at shoot fresh weight, and that's what this axis is here. This is shoot fresh weight. So this first bar here is what they call a healthy control. So those are healthy plants that were not treated with a pathogen. This next bar is called the pathogen control. So these are plants that were treated with a pathogen, the Pythium. This next bar are plants that were treated with the Pythium material, as well as a product called Rhizosphere, which is a very common chemical fungicide. And then this bar represents those plants that were treated with a pathogen and Actinovate. And remember, what we're measuring here is shoot fresh weight. And you can see that this bar here, the plants that were treated with Actinovate, certainly is the highest of all. And to me, this screams Pgpr effect. So we're eliminating the pathogen and we're allowing the plant to grow. And that is exactly what we're showing here in this bar with the shoot fresh weight. All right, here's some more data. Here's one on powdery mildew of peppers, and this one is on foliar blight and Pythium root rot of peppers, 2 different trials. This axis here, we're measuring percent disease. This is the control. This particular one is a Quadris plus Rally. That's a combination of 2 chemical fungicides. And here we have Actinovate. So we're seeing a very nice reduction in the percent disease for powdery mildew on peppers. And remember, this is a foliar disease. Again, another trial in peppers by Sally Miller at Ohio State University. Here we have, and what we're measuring here is we're measuring marketable yield in tons per acre. Here are the untreated plants. So these plants had pathogen. These plants were treated with Rhizosphere Gold, and these plants were treated with Actinovate. Here again, we're seeing an increase in growth measured by yield in tons per acre. So we've eliminated the pathogen or reduced the pathogen effects, and we're allowing that plant to grow naturally. Here's some results of a field trial in strawberries against Verticillium wilt, which is a soil pest. I think most of these products are either biological or OMRI type products. And here you have Actinovate at 2 different rates. And what we're measuring here is total yield in grams per plot. So these were 2 harvests, the first one in April and the second one in May. At the top here, we have the untreated control. So these are plants that were not treated with a chemical or a biological, but they definitely had Verticillium on them. And you can see the significance of that pathogen and how it reduced the yield in the plots. Down here at the bottom, we have our friend Actinovate. This first one is 6 ounces followed by 3 ounces. And then the second one is 6 ounces followed by 6 ounces. Right now we go back to another foliar pathogen, Botrytis. This test was conducted in California. Doug Gubler and his group there. And what we're measuring here is % disease incidence, 0 to 100 scale. Actinovate had the lowest at 5%. Here's a product called Vanguard. That's a chemical fungicide. Here's the control plots. And then here, this is very interesting. This is a chemical fungicide, Vanguard, followed by Serenade, which is a biological. That one didn't do well at all. Again, Actinovate is shining here against this foliar pathogen. Here's another foliar pathogen in grapes, powdery mildew. Again, done at University of California, Davis by Doug Gubler and his group. We're measuring % disease severity. Actinovate. This is Raleigh and Flint, which is a combination of 2 chemical fungicides, and there's the control. So Actinovate is able to work in the soil and on the foliage. That makes it a pretty unique product. All right, one more slide on trial data. This one is against Rhizoctonia, a soil pathogen in both potato and sugar beet. We did trials in Michigan as well as in Washington State. This is a single application of Actinovate AG applied in furrow at planting. What we're measuring here is disease incidence in all 4 of these graphs, disease incidence across this bar. The untreated has the highest incidence in this case. Now here we used different products, but we grouped them by classes. So these are the strobilurin type products, and these are SDHI products. And then finally on the far right in each graph, we have Streptomyces, which is Actinovate, of course. And these letters denote statistical differences. So here we're measuring disease incidence, remember. So with the strobilurin, we're getting a much lower disease incidence than the untreated. In all cases, we're seeing a reduction with all products, but Actinovate is performing as well as the chemical standards. And that's really the bottom line from these trials. Actinovate performed as well as the best conventional fungicides, whether they were strobilurins or SDHI type fungicides. And that's very key because, again, it goes to working in a pest management program and working in a resistance management program. We've all heard about the issues with resistance to chemical fungicides. All right, let's talk about some best practices now. I think I've said this a couple of times, but I'm going to say it again. With Actinovate, you must be proactive. You have to give the good guys, and that's the Streptomyces Lydicus. You have to give them a head start, get them in as soon as you plant that seedling or seed, get them to start to germinate and grow in that rhizosphere to protect the plant. Actinovate is a preventative material. It is not a curative material. And again, Actinovate contains living organisms, and they need to be alive to be effective. So please store and handle the product according to label instructions. All right, a quick overview of Actinovate features and benefits. We talked about broad spectrum activity. I believe Blair is going to go into a little bit more detail on what pathogens that Actinovate is very strong on. We talked about the multiple modes of action, great for IPM, great for resistance management. Actinovate has a 1 hour restricted entry interval, so you can go into that field or into that greenhouse 1 hour after application without any protective gear. Actinovate is labeled by OMRI, so it's listed for organic use. There is no PHI or pre-harvest interval, so Actinovate can be applied right up to the date of harvest. There are no harmful residues, and this is, again, this is an EPA registered product, and EPA has declared that Actinovate is MRL exempt, and that stands for minimum residue limits. So there are no harmful residues to worry about. Actinovate is tank mix compatible with many products. And finally, Actinovate is very safe. It's safe for the people that are using it, the people that are handling it, mixing it, spraying it. It's very safe for crops, no phytotoxicity, and it's also very safe for consumers. Those people that are consuming the product that you're growing, whether it's a fruit or a vegetable or an ornamental plant, you don't have to worry at all about any residues for that final consumer. And with that, I will turn it over to Blair to finish us off with some more information about Actinovate.
All right. Thank you, Randy. I appreciate everybody joining in today's webinar on Actinovate. As you can see, there's a lot to learn about Actinovate, and that's one of the reasons why we wanted to put this special webinar together about the product, because even though it's been in the market for 15 years, there's a lot that we're all still learning about it, and the multiple capabilities that the product does have that makes it continue to be a great product today in 2021 as it was when it was first introduced. The product was, let's go back and talk about a little bit of the history about Actinovate. Actinovate was commercialized by a company out of Florida called Natural Industries, who worked and promoted and did a great job at introducing the product to the market. In 2012, it then became acquired by Novozymes, and then eventually became a product that was part of the BioAg Alliance with Monsanto. And then ultimately in 2015, our parent company, Valent Biosciences, became the master distributor for Actinovate. And then ultimately in 2019, the BioAg Alliance was dissolved and the Actinovate label went back to Novozymes. So maybe you're probably wondering, how is Mycorrhizal Applications involved with Actinovate? Well, we're the primary distributor of Actinovate to the turf and ornamental industry in the United States. Other Valent Group companies, including Valent USA, is the master distributor for the agricultural market in the United States, and Valent Canada and Valent Mexico are the master distributors for Actinovate in their respective markets. So what's new about Actinovate? As we said, it's been around for 15 plus years. There's actually quite a bit that's new. In recent years, we have moved to the 1 year shelf life, which is a very important and unique feature of Actinovate. Compared to most biological products, that this is a very long tenured product on the market. Second thing, it has very simple storage conditions. Normal warehouse conditions, 80 to 85, keep it cool, dry, out of direct sunlight. No refrigeration is needed. So that makes it really a great product for growers as well as homeowners to be able to store the product, be able to use it, and be able to get the full value of the product that's contained within it. The next thing is, thankfully, Novozyme, when they took back the registration, they moved to a national label, where there used to be a California and a national label. So now there's a national label for the Actinovate Ag and the SP. And now starting in March of 2021, there is a national label for the lawn and garden version of the product. Then the other positive thing is now Novozyme is going to be back as the registrant on the label. And another interesting fact is that the manufacturing location for Novozyme for Novozyme's production of Actinovate has moved from its location in Houston to its new location in Milwaukee. So there's a whole new production line and production processes to be able to produce the Actinovate coming out of their new facility that Novozyme has had for years for other products, but now Actinovate will come out of that same facility in Milwaukee, Wisconsin. All right. Another question I frequently get asked is, what's the difference between Actinovate Ag, Actinovate SP, and Actinovate Lawn and Garden? Well, the most important thing to understand is that the product contained within each of those products is the exact same. So the homeowner is using the same product that's being used in agriculture, that's being used by commercial growers. And it's because it's such a safe, versatile product that whether you're growing your home garden or you're using a commercial agriculture, or you're producing petunias and impatiens as a commercial grower, or you're a landscaper, it works in all of those applications. And the other interesting part is that it's so versatile that no matter the industry you're in, you think about it, the types of plants being grown in agriculture is very different than a nursery or a turf application, golf course, or the wide variety of situations which a homeowner might use the product. So Actinovate truly is a very unique product. All right. I'm just like all of you. I want to maximize the value that I have when I purchase a product. And so part of it is also understanding kind of those small little factors that will allow you to get the maximum value of it. And so I wanted to go over the next 2 slides talking about some of the suggestions that basically they're coming from the label, but things that people might not quickly pick up. First of all, I'd like to start off with the point that Randy brought up earlier, and we keep re-emphasizing this part, is that the product is a better preventative than a curative. And that leads to this second line on this slide, that you need to give the home team, being Actinovate, that 48-hour window to be able to effectively establish itself. And it needs to establish itself, as Randy talked about, so that it can physically block out the pathogens that might come in, but also to chemically and be prepared and establish itself and start that relationship with the plant in the rhizosphere. So that's very important to understand. The next thing is Actinovate can be combined with traditional chemical fungicides. As we all know, we talked about resistance management, and Actinovate is a great product that can be rotated in, and it works very effectively with chemical fungicides. Versatility is another factor. As we're getting here with baseball season, you think of the utility player that can play all the different positions in the field. That's the same way you can think of with Actinovate. You're going to apply it as a soil drench. It can be used as a root or a plug dip, or it can be a foliar spray. So it has a great application options. And depending upon what you're trying to control, you can apply it in many different ways. All right. Now, one of the challenges many growers face that maybe are in more urban situations is they're dealing with chlorinated water. Now, if you want to get the maximum value of your Actinovate application, you're going to want to use dechlorinated water. So we suggest that you work with your local water official to come up with a plan that you can get a source for dechlorinated water at your nursery or greenhouse or landscape situation to be able to maximize the benefit. And the last thing on this first slide is that you're going to get maximum performance when temperatures are above 45 degrees Fahrenheit or 7 degrees Celsius. So it's critical for you to understand that basically they need some warmth so they can get their activity going, and to be able to create those barriers and to perform the processes that Randy talks about in how they work to prevent pathogens from being able to come in contact and have disease impacts upon the plant. All right, slide 2 here as far as maximizing the value of Actinovate. The first thing is to understand reapplication timing. So in a soil, Actinovate has a really quite a long period of time in which it can be effective. It's 30 to 45 days. And then you can just keep reapplying it during that period. On a foliar application, you need to reapply it every 7 to 14 days. It's a lot more complex surfaces on the soil, on the foliage, I should say, of a plant. And so that's why you need to have to reapply it more often than you would in the soil. All right, Randy talked about this earlier. The reentry period is 1 hour until, when Actinovate is dry, very short period. So that's a wonderful thing. It gives lots of flexibility for growers, or if you're in a situation where the public is present in a landscape situation. Watering, it's suggested you don't water within the first 4 hours after application, giving full chance for the Actinovate to dry, but also for it to start to establish itself before watering could go through that could displace it. The next thing Randy talked about earlier, also the pre-harvest interval of 0 days, very important, so that you can harvest the plants that you're going to be putting on the racks to be able to ship off to the customer, or if you're producing fruit or anything else that can be immediately used and sent out. The last point is that as we want to continue to reemphasize, as integrated pest management has become such a vital part of the horticultural community efforts in managing pests, that Actinovate just makes such a good tool for growers to be able to use in their development of an IPM program because of its versatility, multiple modes of action. You know, it works well with other products that you can have in your IPM program. So a very good tool to have there in your IPM program is Actinovate. All right, resistance. Randy talked about this earlier. You know, biological products we typically don't think of as having resistance issues compared to chemical products. But, you know, if we want to put our best foot forward, it should be, you know, rotated, and Actinovate, even with its multiple modes of action, is a great component of a resistance program that a grower can have by having rotation of different modes of action. And the nice part about it with the multiple modes of action of Actinovate with rotating with other products is that your ability to control resistance becomes even stronger. So great tool to use Actinovate as a way to really to reduce resistance and to control and to have good management of resistance in a greenhouse or nursery. Okay, so what are the advantages of Actinovate versus other biological fungicides? Well, first of all, it stood the test of time. Here it's been 15 plus years. You know, it was first considered and evaluated back in the early 90s. So there's been lots of tests and trials, both in agricultural, in horticulture, and at the home garden, and it's continued to perform well and had great acceptance by all people in the industry. Second thing, it's broad spectrum of disease prevention and control. So it works on both foliar diseases as well as soil-borne diseases. So, and it works to control and does a great job. The next thing is a growth promotion. Randy talks about the aids in the uptake of minerals and nutrients. You know, I can't overemphasize the importance of, if you're using growing plants like Calibrachoa, spreading petunias that are very high in their needs for iron. There's other crops out there like that. You know, the addition of Actinovate in your program could really help in being able to uptake of those minerals into your, I should say, those metals into your plants to be able to help them and combat iron chlorosis and other conditions. Promotes increased plant growth and plant size, the Pgpr effect that Randy talked about, and can be combined with other chemical fungicides, pesticides, so it's not impacted by whatever you want to apply. and it's compatible with other biological fungicides. So if you're looking at a rotation program, it's different modes of action. So if you're looking at other products that are on the market, another a bacterial product or a biological fungicide that uses some type of a fungal organism, it works very well with all those. And so it's important to understand that they can work well together. And the other thing, basically, it helps the plant in helping to control and suppress disease, as well as the plant growth promotion factors to be able to give you a better, stronger plant that can handle other stresses that can be brought about by the plant. All right. I often get the question, you know, obviously I work for Mycorrhizal Applications, and our primary product is the MycoApply product line. So I often get the question, how does Actinovate work with mycorrhizae? And the short answer is they work very well together. As Randy talked about, that the Actinovate is working to create, and it feeds off of the different exudates that the plant produces or other things that are found in the soil. The mycorrhizae itself basically forms a relationship with the plant. And so they become physically connected, and by becoming physically connected, the plant gives the lipids and sugars to the mycorrhizae, allows them to grow and to progress and be successful in return. The mycorrhizae is working to give water and nutrients to the plant. So those activities of the mycorrhizae are totally separate. And so if I kind of consider it, they're in different lanes, but they're both in the rhizosphere, but one they're performing totally different. And the Streptomyces and the mycorrhizae can work very effectively together. And in some instances, we've actually seen that there is some synergy between the two working together. All right. Here comes from the bad news for many of you. I get asked almost every trade show, when is Actino-Iron going to come back? Well, after consultation with the manufacturer Novozymes, we've been up. The latest update is that there is no plans to reintroduce Actino-Iron back to the market. Well, the good news I have for you is if you go to the Actinovate label, that it does clearly explain how you can add Actinovate to this growing media. So if you're doing and blending your own growing media, or you are bringing in a pre-manufactured growing media that you want to incorporate something into it, you can incorporate Actinovate directly into the growing media and get some of the benefits that you achieved and liked that were found when you incorporated Actino-Iron directly into your soil media. So bad news, Actino-Iron is not going to be available. Good news, it is on the label that you can purchase and use Actinovate as a component when you're blending into your soils and get some of the great benefits Actinovate that you've come to know and like about Actinovate in your soil. Okay, another commonly asked question I get, as we all know in the horticulture market, you know, the hemp market, many growers are using hemp to fill part of their production space that they have available, and so hemp has really become an integrated part of our market, particularly when we're focused on CBD hemp. As we all know, that the hemp is produced in greenhouses, it's with cuttings or with feminized seed, so it's very much ties into just a typical normal production, just like you might do with poinsettias or other types of items that you propagate through vegetative or specialized seed. So important thing to understand is that hemp is not currently on the Actinovate label, but there are several states that have Actinovate on their approved list for hemp production. So, and as you think about some of the traits that Randy brought out earlier, some of those positive traits that Actinovate has as far as reentry, as far as transferability and other things, make it often a desirable product to be used by people growing hemp. All right, let's move on to the top 5 pathogens, the first being Pythium. And when we think about Streptomyces Lydicus and how it works with the pathogen, it is great because you think of all the diverse modes of action, whether it's competitive exclusion, antibiosis, or any of the others that are listed on this slide. They all work together to combat the powerful pathogen of Pythium. And basically, this goes back to where we're going to, and you'll see this repeated in almost every one of these slides when we're talking about the top 5 pathogens. If you give that Actinovate the head start so that it can establish itself, we're saying about 48-hour period, it can colonize and effectively shield the plant from Pythium, negatively impacting the plant. Rhizoctonia, another disease. You can see there was a few actually slides that even Randy shared that showed how it performed against in trials and other experiments. But basically, Rhizoctonia is a disease that we have good examples of where Actinovate has performed as good or better, depending upon the trial, compared to some of the major chemical classes that are used in both the that are used commonly in our industry. So if applied ahead of time, given a chance to establish itself, Actinovate can perform very effectively against Rhizoctonia. Powdery mildew. You know, and often I think about powdery mildew, I think about a customer that I was talking to a couple years ago that was growing pumpkins. And they were working to combat powdery mildew, which we all know we've had that affected, particularly when you get the fall cooling effect and moisture gets on the leaves and the powdery mildew starts developing on the plant. Well, this grower indicated to me that Actinovate, they had started using it and become an effective way for them to be able to control powdery mildew on their pumpkins. So this foliar disease is can be effectively controlled by Actinovate, and unlike other types of organisms, as you see, it needs to keep that leaf alive or the plant cells alive so that it can keep feeding off of them. And this is where that mode of action, the SAR and the ISR induction modes of Actinovate come into play. They work to form basically an immune response, and so that they can work and combat the negative impacts of powdery mildew on the plant. So again, Actinovate can effectively work on the control of powdery mildew. Fusarium, very tough disease, particularly once it gets established and entrenched in the vasculature of the plant. So again, if you apply it early, give the plant that 48-hour period to establish itself so it can create the chemical and physical barriers, it can effectively control the fusarium and can really control and have great effect against this devastating disease. And the last disease I'm going to talk about today is Botrytis. So when we think about Botrytis, it is, you know, we gave examples of grapes. This is an example of berry. When you think about going to the grocery store and all of us are buying those small containers of raspberries, or we're buying strawberries or blackberries or other things, you were wondering, why are those beautiful plant berries available all year round? Well, we work with some of those large growers and they use Actinovate to treat their plants and to control Botrytis on them so that they can have those beautiful plants all year, whether it's produced in Mexico or in the United States throughout California. So it has shown itself there. That same level of performance can also happen to you in your when you're producing bedding plants or nursery plants, that Botrytis can be effectively controlled with the use of Actinovate. You know, this testimonial is really a typical testimonial of people when we are at a trade show or we're getting emails from people that they've had such a positive experience over the years of working with Actinovate. And once they've had that positive experience, when they move on to another job, which often happens in our industry, that the grower wants to take that knowledge and that positive experience they've had with Actinovate and use it to move forward and use it as part of their IPM protocols in controlling diseases in their new position. Okay, last but not least slide here, let's talk about Actinovate. So it's such a wonderful product. You're probably wondering, well, how can I get it? Well, we sell Actinovate through a great group of distributors that we have throughout the United States. And if you go on our website, you can click on the state you're in and find out where you can purchase the Actinovate. Actinovate is available 12 months a year. I know there's people growing 12 months of the year. There's fresh product available. And as you know, with the 12-month shelf life, it can effectively work on a wide variety of crops. But we suggest you go to our website and work with our great distributor network to be able to source the product and be able to get it out to your growing operation, to your nursery, your greenhouse. If you're a homeowner, you can get it through a group of our retail distributors and be able to pull that out and be able to utilize it and take full advantage of it. As mycorrhizal applications, we sell the Actinovate Ag, which in its new format is a 5-pound bag, as well as the Actinovate SP, which is an 18-ounce bag. And then we have the Actinovate Lawn and Garden, which is an 18-ounce bag, and that also has the UPC code on it. So those three are all available from us. And so what we'd like to do is to turn it over to questions. So what questions do all of you have for us today?
All right. Thank you, Randy and Blair. Really good stuff on a green and safe biofungicide product there in Actinovate. We've got some really good questions here. I'll start off. The first one, I'm going to throw you a little curveball here. This will be a two-parter. How pH sensitive is Actinovate, and will Actinovate decrease the effects of compost tea?
Okay, my suggestion, let's start with the compost tea question. Just like with any other, compost tea is a live product, just like Actinovate. And so if you're going to apply Actinovate to a plant that has been treated with compost tea, so you're applying it as a drench, there shouldn't be any negative impacts, because the compost tea basically completes its process before you apply it. And so that the Actinovate that is applied in the soil I don't think should have any problem working with the compost tea. In fact, we have some distributors that actually are compost tea suppliers that it has worked effectively. Your second question, as far as the pH, there's no information on the label that specifies any issues with pH. I would assume if you're using any somewhat normal range of water with pH, there shouldn't be any issue. So hopefully that answers your question. It's more of the chlorination of the water. What is the issue that we just ask people to try to fix before they use it in any application.
Excellent, gentlemen. Another question that just came in: can this product be used in soilless cultivation? So I guess hydroponics and other soilless mediums.
So certainly in peat-based media, which is a soilless media, that's the most commonly used in greenhouse production. In terms of hydroponics, I think it really depends exactly what your hydroponic system is. I know it's been used in a variety of hydroponic systems that use the I can't think of the name of it, the spun glass material. That should be effective, because that's a medium that allows the Streptomyces to germinate and grow on the root system. But you do have to be a little bit careful about flushing too much water through there. Just like Blair said, even in a drench situation, you'll want to make the application of Actinovate and allow it to become established before you start flushing a lot of water through that system. Blair, anything to add to that?
I was going to say that's similar to what we talk about with mycorrhizae, is that generally you're going to get the best type of performance from one of these Rhizosphere type products if you have some type of something kind of supporting the Rhizosphere rather than just a totally open system. So I agree with what you've just said.
Excellent. Thank you, gentlemen. Another question: does Actinovate have effectiveness or activity to contain root knot nematode?
Yeah, I'll take that one. That's an easy one. The answer is no. Actinovate is not a nematicide. It's an EPA registered fungicide.
Okay, that solves that then. Is Actinovate labeled for use with any adjuvants, for example, turbo, for better flow, or can you use it with sticking agents in a foliar application?
Well, I don't know of any particular trials with different types of additives on the application of Actinovate, but anything that you can, when you apply it to particularly the foliar application, anything that you can get it to, to stay on the foliage of the leaf to increase the basically application rate of the product would be a positive. Typically, I don't think you're going to need anything with the soil, because as long as it's more of the placement, so that the Actinovate is placed by where the roots are actively growing. And as long as it's placed there, it's going to start to form the relationship with the plant roots, and then will spread throughout the root system as the Actinovate continues to grow.
Excellent. So we are getting close to the end here, folks. We've got time for about one more question. I do want to let you know that, though, that we will turn these questions over that weren't answered during the Q&A period over to Mycorrhizal Applications, and they will follow up with you when they can get to you. So the last questions today is, can you recommend any other biofungicides that you would want to rotate with Actinovate? And how often would you recommend rotating Actinovate to avoid resistance?
Yeah, I'll take the second part of that question first. How often should you rotate? So if we're talking about rotating with chemical fungicides, most people probably have an established rotation program, and I would put Actinovate right into that program. So it kind of depends on what the target pathogen is and what the mode of action of the fungicide is. How often you should rotate, and some of those rules have been established by the fungicide resistance group that has put some recommendations out there. So it kind of depends. I would certainly say that the incidence of resistance against biologicals is going to be much more rare. So if you're an organic grower, rotating with other biologicals is certainly recommended, but we certainly do need to take care of these products so that they last longer. I hope that answers the question.
I think it does. All right, we are up against it. We're out of time here. So I wanted to, first of all, thank our sponsor today, Mycorrhizal Applications, for the informative and interesting hour of content here. I want to let everyone know that this presentation will be available for download in the next few days. So check back with us at greenhousemag.com to download your record of this. Thank you, everyone.